Welcome to section 7.5, where we will talk about probability using the fundamental counting principle. We'll use permutations and we will use combinations. Let's look at our objectives. So our objectives are, can we compute probabilities using permutations? Can we compute probabilities using combinations? And I need you to remember that probability of an event E happening is the number of ways that E can happen divided by the total number of outcomes for the situation. And we're just going to dive into some examples, and we have to be able to count the number of ways that things can happen. So let's get some examples. Example 1. 6 jokes about books by Groucho Marx, George Carlin, Stephen Wright, Greg Ray, Jerry Seinfeld, and Phyllis Diller are each written on one of 6 index cards. So 1 joke per card, 1 from each of the comedians. Notice that Phyllis Diller is the only female in that group. The cards are placed in a hat and drawn one at a time. What is the probability that a man's joke will be delivered first and a man's joke last? So the notation we're using for this situation, the probability that we have a man's joke first and a man's joke last, and then back to our equation for probability, it's the number of permutations that have a man's joke first and a man's joke last divided by the total number of possible permutations. Okay, so what we're going to do is we're going to calculate this number from the denominator first. So we're going to calculate the denominator first. So this calculation is going to do our denominator. And for that denominator, it's just the number of ways that we can order 6 different things. In this case, 6 different jokes. So that would be 6 times 5 times 4 times 3 times 2 times 1. So it's the fundamental counting principle, but it's also permutations. We're ordering 6 different things. So the number of possible permutations and the number of possible orders for those 6 jokes is 720. You can do 6 factorial on the calculator, or you can do 6 times 5 times 4 times 3 times 2 times 1. Either way. So we get 720. Now we're going to look at how we come up with this denominator. Oops, we've just done the denominator, sorry. We've just found the denominator. The denominator is going to be 720. So it's something over 720, right? That's our denominator. So let's find that numerator. So I'm going to move to my next slide where we're going to calculate the numerator. The number of permutations where we have a man's joke first and a man's joke last. So let's do that calculation. So we're going to use the fundamental counting principle to do that. And the way to think of it is we've got 6 things that we have to put in order. Okay, 1, 2, 3, 4, 5, 6. The first joke I want to be a man's joke. So there are 5 possibilities for that. But now I'm going to actually fill this one second. This last one right here, I'm going to fill that one second because I need that one to be a man's joke as well. And the only 2 that have a restriction are the first and the last joke. So there are 5 possibilities for the first joke. And with that in mind, there are 4 possibilities back here, because if that's a man's joke, there's only 4 men's jokes left. So that would be a 4, right? Now let's fill the rest of the possibilities. What are the number of possibilities here now for the second joke? So I've used 2 out of my 6 already. So there's only 4 left. And now there's 3 left. And now there's 2 left. And then there's only 1 choice for that joke right there. So the number of ways that we can order the jokes, if the first one has to be a man's joke and the last one has to be a man's joke, is 5 times 4 times 3 times 2 times 1 times 4, which is right here. So the number of different options there, the number of different ways we can order the jokes if we have to have a man's joke first and a man's joke last, is going to be, do that calculation, we get 480. Okay, so the probability that we have a man's joke first and a man's joke last is going to be our number of ways we can order with the man's joke first and the man's joke last, and then divide by the total number of outcomes, which, as we saw in the last slide, is 720. And then we're going to reduce that fraction. Now, I'm going to show you how you can reduce it quickly on the calculator, because we are going to leave lots of our answers as fractions, so we need to understand how to do this. So I'm going to do it on the calculator. I've got 480 divided by 720. Oh, that's 2/3. If you recognize it, it's 2/3. If you don't recognize it as 2/3, that repeating 6 is a 2/3. The calculator, of course, rounds that last digit to a 7. But it's 2/3. If you don't recognize that, you just push math and choose option 1, and it will change your previous answer to a fraction. So I push enter, and it will change that 0.666666 to a fraction. There it is, 2/3. Okay, so reduced version of that fraction is 2/3. Okay, all right, we're going to move on to another example. We're going to calculate the probability of winning Powerball. So in this particular situation, the Powerball that we're looking at, Powerball is set up so that each player chooses 5 different numbers from 1 to 69, and they choose one Powerball number from 1 to 26. With one Powerball ticket, what is the probability of winning this prize? So in this kind of competition or game, the order of the 5 numbers does not matter. Okay. So this situation is going to be using combinations. Order doesn't matter. Order does not matter, so it's combination. And the probability of winning the jackpot. So we want to know what the probability of winning the jackpot is. It's going to be the number of ways of winning the jackpot, that's our numerator, divided by the total number of possible combinations. Well, there's only going to be one winning possibility, one winning list of numbers. So it's going to be 1 over something. So our job is to figure out what that denominator is. What's the total number of possible combinations in this situation? Well, we have to do 2 things. We have to choose 5 numbers from 1 to 69, and then we have to choose one number between 1 and 26. Now, there is a typo in here that I want you to fix. This should be 69 right here. So the first thing that we're going to do is we're going to choose our 5 numbers between 1 and 69. So we have 69, choose 5. We're choosing 5 numbers out of 69. Okay, and the formula for calculating that is right here with the factorials. And we're going to go through that the long way. But then we also have to choose our Powerball number from 1 to 26. So we do the number of ways we can choose 5 out of 69, and we multiply by 26 because we've got 26 choices for that 6th number. Okay, that's where the 26 comes from. So we're going to do 69, choose 5 right here. And then once we've done that, we're going to multiply that by 26 to get our one Powerball number that's chosen between 1 and 26. Okay, so let's do this calculation. So we're going to do 69 factorial over 69 take away 5 is 64 factorial. We'll do a little expansion. Remember, sometimes we have to do this because our calculator can't handle some of these big numbers. So we'll do 69, 68, 67, 65, 64 factorial, because we're going to let that cancel with the 64 factorial in the denominator. If you remember how to use the calculator, you can do that as well. I'm going to go ahead and expand that 5 factorial as 5 times 4 times 3 times 2 times 1. 64 factorial cancels. And I can do that on my calculator. Let me pull up the calculator, show you how to do that on the calculator. If I want to do 69, notice the parentheses. You got to have the parentheses. 69 times 68 times 67. I'll just put parentheses around the numerator and the denominator. Times 66 times 65. And then divide by and use those parentheses around the denominator as well. Now you can either use your factorial button on your calculator, or you can do 5 times 4 times 3 times 2 times 1. And of course, the 1 is really unnecessary because it doesn't change anything here. Or you can use the factorial button on the calculator, the factorial feature. It's not a separate button, but the factorial function. Push enter. We get a big, big number. 11,238,513. So let me write that one down, and then I'm going to do another calculation. Okay, so here's my 11,238,513. And then I'm going to multiply that number, which is still in my calculator, times 26. Okay, that number that's still in my calculator, I'm going to multiply it by 26. There it is. 292,201,338. Okay, so that's going to be 292,201,338. And then on to the probability. Probability of winning the jackpot. There's only one winning lottery combination. There's only one combination of those numbers that's going to win, and there are 292 million possible picks. That's really bad odds. So if you plug that number into your calculator, you come out with 3.4 times 10 to the negative 9, which is a lot of zeros. So it's really, really small odds, really close to zero. 1, 2, 3, 4, 5, 6, 7, 8. 10 to the negative 9 is 8 zeros followed by that. That's the scientific notation for 3.4 times 10 to the negative 9. Really bad odds of winning. Okay, let's move on to the next example. Example 3. Probability in combinations again. So a club consists of 5 men and 7 women. These numbers are going to be a little bit smaller. The club consists of 5 men and 7 women. So we've got 12 people total in the club. 5 plus 7, 12. So 3 members are selected at random to attend a conference. Find the probability that the selected group consists of 3 men. And then in part B, we're going to do a different probability. We're going to calculate the probability that there's 1 man on the committee and 2 women. So we have 12 club members and we're selecting 3. Now, if we are choosing 5 or 3 out of the 5 men in part A, let's do part A first. So order of selection doesn't matter. So this is a problem that involves combinations. In the committee, we're not putting those people in any kind of order. So it's going to be a number of ways of selecting 3 men out of 5 divided by the total number of possible combinations. So this is going to be my numerator right here, and this is going to be my denominator. There are 5 factorial over 5 minus 3. 5 minus 3 factorial times 3 factorial. Or you can use the calculator to do this. That's 5 times 4 times 3 factorial over 2 factorial 3 factorial. We're going to let that go away. 2 factorial is just 2. I've got 20 divided by 2, which is 10. And then 12 choose 3, or 12 combination of 12 things taken 3 at a time would be 12 factorial over 12 minus 3 factorial times 3 factorial. We'll just do 12 times 11 times 10 times 9 factorial. I'm going to stop there because 12 minus 3 is 9. That's 3 times 2 times 1. I'll let those go out. 3 times 2 is 6. I can divide that into the 12, or just use my calculator, whichever. But that's 22 times 10, or 220, right? So that is, when it's all said and done, 10 over 220, which is going to be, let's reduce that. What does that reduce to? 1 out of 22. And then if you need a decimal, we can change it to a decimal. Okay? If you needed a decimal, we could easily change it to a decimal or to a percent. Let's look at part B. So the probability of 3 men on the committee is 1 out of 22. Okay. Let's go on to the next one. Probability that there's 1 man and 2 women on the committee. So the order of selection, again, doesn't matter, so this is going to involve combinations. So we're going to look at probably there's 1 man and 2 women. That's the number of ways of selecting 1 man and 2 women divided by the total number of possible outcomes. Well, we're going to work on the numerator first. Okay, we're going to work on that numerator first, and then the denominator is just going to be a 12 choose 3 again. It's going to be the same denominator as the last part. Okay, it's going to be our 12 choose 3 again. So that we've already got that number from part A. So we really just need to work on finding that numerator. So we're going to use the fundamental counting principle here, and we're going to take the number of ways we can select 1 man out of 5, that's here, and then we're going to multiply that with the number of ways we can choose 2 women out of 7. So this is just 5. We're choosing 1 person out of 5, so that's going to be 5. I'm not even going to bother to put it in the formula. There's only 5 possibilities here. We're choosing 1 out of 5. But on this one, we're going to do 7 factorial over 7 minus 2 factorial times 2 factorial. Let's go 7, 6, 5 factorial. 7 take away 2 is 5 factorial. Cancel, cancel. I've got 42 over 2 because 2 factorial is just 2 times 1. So 42 divided by 2 factorial, that's 21. Okay. So then we're going to multiply those two together. Oops. So we're going to multiply those together, the 5 times the 21. That's going to be our numerator because we're choosing 1 out of 5 men and we're choosing 2 out of 7 women. So the total number of ways we can choose 1 man and 2 women is going to be 5 times 21. All right, let's move on. I'm going to move on to the next slide. So fundamental counting principle, we do 5 times 21, which is 105. And we can now fill in the numerator and denominator. This is the same number we had in part A. 12 choose 3. That's our denominator. We're choosing 3 people out of 12. So our probability is going to be 105 for the numerator. Number of ways of selecting 1 man and 2 women. And our denominator is 220. And then if we reduce that, let's go back to our calculator. Let me clear that out. That's 105 divided by 220, which is going to be 0.4777. If I needed to round that to any kind of decimal, I could do that. Or if I need it as just a reduced fraction, which a lot of questions are going to ask for reduced fractions, I just take my decimal answer, switch it back in the calculator, will reduce it for me. So 21 out of 44. We should be able to reduce the fraction by taking out a 5. That's all you can get, really, is a 5. But 21 out of 44 is our probability, or 0.477, right? 0.477. And again, just pay attention to how many decimal places they want you to round things to. Okay, and that is the end of our notes. Good luck with the homework.